In the last lecture, we have gone through the introductory discussions towards linked list. Uh, we have seen how a memory is managed and what are the advantages and disadvantages of using arrays. We are not comparing, we are not saying that one is better than the other. Of course, both are widely used, both data structures, that is array and linked list, are widely used to implement various data structures or organize data or store data, but both have their own advantages and own disadvantages. So we have seen what led to the need of implementation of linked lists. That is, when we are using arrays, those arrays are stored in a contiguous memory location, and we need to predict the size of arrays or number of elements to be stored in the array well in advance. So these were the issues in which we were not able to use the memory efficiently. This disadvantage led to the implementation or innovation of linked list, and this linked list was helping us to uh, use the elements or store the elements dynamically. As and when element comes, you store it anywhere and just provide its address to the previous element. That was a simple logic behind implementation of a linked list. That's what we have seen. We'll go for the same discussion. This is a little lengthy topic and a little difficult to understand. So please concentrate and go on seeing this lectures repetitively if you have not understood it. Okay. So I've given the analogy for this is the people who are holding hands with each other. That is one chain formation or a train or a kind of treasure hunt. These are the analogies which we try to use. Okay. And these were the diagrams through which we are trying to understand what linked list is. So in linked list, the elements are chained or connected with each other in such a way that can traverse all the elements one by one. Okay, but only thing is when we come to the first node, we will come to know the address of second node. Second node will give us the address of third node. Third one will make us reach to the fourth one, and fourth one will have address of the fifth one. So not first is directly first can directly access uh, fifth one or fourth one is not possible. So one by one, gradually we are going to access that linked list. Okay. Uh, all these nodes are stored at scattered memory locations, different memory locations. If we are going for this diagram to understand, this will be better to understand. In this is if we had array to store these four elements, the structure would have been something like this. Let us say that this is 3, 17, and 19. So the structure would have been something like this, and this would have been the first index, second index, third, and fourth, and we would have given some name to this. So this is named as A of 0. This will be named as A of 3. So these were the notions which we are using when we were talking about the array. But only thing is, if this is the base address, this is the address of its first element, then all the other elements will be at a particular distance uh, from that element. So if it is an integer and it is taking 4 bytes, it is sure that this is going to be stored at 100, 101, 102, 103 will be consumed by this, and 104 will be the location for this. This will have location 108, and this will have a location 112. Okay, on which basis we are calculating? We are calculating it on the basis of base address of this array. Base address is 100. Then at every fourth location, there onwards, we are going to have the next element of the array located. So with the help of first element, I can make access to any of the elements in this array because they are sequentially uh, stored, and also they are stored in a contiguous memory location. So we need to know only the base address, and then we can access all the elements. At a particular distance, they'll be stored. This is the structure which we are using, but the same structure is, same values are stored with the help of linked list in this fashion. Okay, we are going to have the data stored at some random location. Wherever we get that particular space free, that will be stored there. Okay, so like here 3200, at 3200 we have stored 15. Then 3 came into picture. It is also stored at some location wherever it has found space. That is 3600. Only thing which we are taking care is this address need to be fed to the previous element. Okay, so after 15, where we are supposed to go? We are supposed to go at location number 3600. After 3, where we are supposed to go? We are supposed to go to location number 4000. So after 17, where is the next element? It is stored at 4400 location number. After 90, what element you are going to access? I am not going to access any element. So its address field is made as null and it cannot be accessed. Okay. So this is the way we are designing a linked list. Okay. Now, how that node can be stored? How that node can be declared? See, this node we are constructing, we can construct the node as per our convenience. That means I want integer value to be stored. I am going to have the data field as integer. Okay. If I want a character element to be stored, I can make data field as character. Okay. So we can construct the node by ourselves. This is a user-defined data type, but it needs to follow a particular structure. Every node in the linked list or every element in the linked list is going to have 2 fields. One is a data field, another is a pointer field. Okay, so it's a group of elements together. It is going to have the data field. Data may contain the value, and the pointer field, the linked field, the next field is going to store the address. Let us say that it stores kind of address at 1000. So this is going to store the data as well as address. This is called as a linked field. This is called as a pointer field, called as a next field, any name you can give. Okay. So the node is going to have 2 parts, data part and the link part or address part, which is going to point to the next element. Next element means exactly similar element. So this can be declared in this way. Struct node. The node is the name of the struct. Okay. What will be the part of it? The data part. It can be integer, character, array. It can be anything. It can be anything. Okay. It may have more than one data fields also. Right now we are sticking to only one data field. So a data field is given, and next is the pointer field. Pointer field. Okay. It's this asterisk indicates that it's a pointer variable. So next is a pointer variable. Next is a pointer variable. What kind of pointer is that? Is it an integer pointer or a character pointer or a float pointer? No, it's a structure pointer. Okay, it's a structure pointer. Then hence we are defining it as a struct pointer. What kind of structure it is pointing to? It is pointing to the similar kind of structure. Okay, it is pointing to the, say, another node of same type, of similar type, okay, of the same definition. Your next node will also be of the same definition. You cannot have nodes of different constructs in the same linked list. If there is one linked list, all the nodes in that linked list are going to be of same construct. So it is pointing to the node which is of same type. Okay, understood? Okay, so this structure is now defined in this. So this is the data field. This is the data field, and this is the next field. Next means the link field or the address to the next node. And this type of next is a structure node pointer. Okay, a very important thing which you need to know is these kind of pointers are called as these kind of structures are called as self-referential structures. I'm repeating, these kind of structures are called as self-referential structures. That means they have one of the member element as a pointer which points to the similar type of structure. So here I'm forming a linked list. I'm forming a linked list which will point to the whose link field will point to the similar kind of node. Okay, so this kind of linked list we can fine. So this is the way we are declaring a structure. Is it okay? Have you understood or anything you want to ask? Then I can proceed with I'll repeat. Anything you wish to ask? Okay, nothing. Now, coming to the most important part, understanding how these linked lists are implemented. Okay, so for that you need to have a clear-cut knowledge of structure, the pointers to the structure, accessing elements of a structure, using pointers, and dynamic memory allocation. These are the things you must know before proceeding further. So let me ask you, what do you mean by dynamic memory allocation and how it works? So this I asked you to do by yourself, if I remember, and now I will see, or I'll ask the question to some particular people, and I expect the answer from them. Okay, so I'll try to get the answer from Sonia. Sonia, are you there? Can you put the mic on, Sonia?
Yes, sir.
Can you tell me what do you mean by dynamic memory allocation? Yes, Sonia? Sonia, I'm audible to you. I'm asking a question to you. Fine? No issue? The one who will not respond me, I'm going to remove him or her from the meeting. There is no sense staying it back there. Okay? Sripad.
Yes, sir. Sir, dynamic memory allocation means the manual memory management of dynamic memory.
Manual memory management of dynamic memory. Okay, a very theoretical answer. Can you just elaborate it a bit?
Sir, in this we allocate or deallocate the memory manually.
Okay. we take the control of memory, allocate the memory or deallocate the memory manually. Yes, very correct answer. Saili, are you there? Saili, are you there? See, those who are not answering, I'll start removing those people. I am removing Saili. I've done. Even Sonia has not answered my question or did not respond. So I'll remove her also. At least respond. If you don't know the answer, there is no issue. At least you are supposed to tell that you don't know. It won't be tolerated that you are just putting your joining the meeting and moving out. Rutuja Dhande. Rutuja Dhande. Rishikesh Nandankar.
Yes, sir.
Yeah. What are the different functions of dynamic memory allocation? Can you name them?
Sir, malloc, calloc,
Huh?
and sir, दो ही याद आ गए.
दो ही याद है. चलो ठीक है. But don't call it as malloc or calloc. Please call it as malloc or calloc. Will always be better to understand. Okay.
Okay.
Memory allocation and calculation of calculation and allocation, right? That is malloc and calloc. So it is easy for us to to recall how it works. Okay, Rishikesh.
Okay.
Good. Can I get answer from Prayushi Khandelwal? Prayushi Khandelwal. Okay. She is also not answering. Vedant Mule. Okay, can you tell the other two, remaining two, whatever Rishikesh has told? The dynamic memory allocation part.
Yes, sir. One moment. So realloc.
Huh?
So one is realloc.
Okay, fine. There are a lot of disturbances on your side, Vedant. Okay, you can put your mic off. So there are four functions which we are dealing with in dynamic memory allocation. Those are malloc, talloc, realloc, and free. So in malloc, we are allocating the memory of a particular size. In talloc, we are calculating and allocating, which is very similar to malloc. So mostly malloc will be used and we won't bother about calculation of the memory and all. Third is realloc. As the name suggests, we are reallocating the space. Sometimes by mistake, we must have overestimated the space or underestimated the space which is required. So at the runtime, we can reallocate that piece of memory to a larger size or a smaller size. And free, as the name suggests, we are freeing up that memory space. Okay, so that's what you were expected to know if I am moving to the linked list. Mostly we are not to use rest of the what we say functions, but we'll be using malloc very frequently. Okay, malloc is the most primary function of your dynamic memory allocation. It is very simple. You know it, or probably few of you may not know it. I'll just explain in short what malloc is. So what malloc is in malloc, we just write this is a keyword which is supported, which is used for memory allocation of a particular size of our wish. So what we'll do, malloc is supported with is passed with the argument called as size of the memory block. So let us say that I want to allocate a space for that similar example we'll take, whatever structure example we have taken. So I want to allocate a space for the structure. So I'll just pass its size. So if I know the size is always good, I can directly write the name, write the size. Otherwise, I'll have to write size of struct node. So what will happen? The size of this struct node will be calculated, and a value will be returned by this size of function, which will be a parameter for malloc. Okay. So let us say that returning. I can directly have an integer value in that. Let us say that the size of struct node is 10. So I can directly say that malloc 10 is also correct construct to use. And if I don't know the size, I will use size of struct node. Okay. So malloc takes the parameter of the size, a number of bytes which are to be allocated for that purpose. And of course, when a block of memory is allocated, that will be pointed by a pointer variable. That will be pointed by a pointer variable. So malloc is going to return a pointer. Fine. So what will happen? As soon as I call malloc, there will be 10 bytes block. 10 bytes block with this example that either I'll supply 10 or I am thinking that struct node size is 10. Okay. Block of size 10 will be allocated. Block of size 10 will be allocated, and that may be stored in some memory piece. Let us say that memory piece is starting from 100. Okay. So 100 to 109 are the locations which are kept reserved for this malloc function. Okay, or malloc function has reserved these 10 locations which are starting from 100. So that means what malloc is returning? Malloc is reserving the 10 bytes and returning its base address. So it is going to return an address. That means it is going to return a pointer. But it doesn't know what you are going to store in that. You have just asked for 10 memory blocks. It has stored it. It doesn't know what you are going to store in that. That's why it is going to return a void pointer. It's going to return a void pointer. Are you understanding? Even though you have supplied the size of struct node, that is going to just return an integer. It doesn't mean that you are going to store a structure variable in that memory block. It doesn't mean that. It means only that just allocate 10 memory blocks and return a pointer of it. So 100 will be returned. 100 is a pointer, is the address of a memory location, base address of the block which is reserved. It is a void pointer. I need to typecast it. So I can write here how I can typecast it. I will have to write the data type to which I want to typecast it. So if I say now what will happen? Now the pointer which is returned is not a void pointer, but it's a pointer for the node. It's a pointer for the node. So I can name it. I can name it as new. Let us say that I'm naming it as new node. So now this malloc function is complete. The malloc function has reserved a block equivalent to the size of structure node, and that will be a block which is going to store the struct node pointer. Okay. Again, go for a simpler example. So let us say that we'll try to store an integer variable. So write malloc here. I don't know the size of integer, what machine I am using, what compiler I am using, what size of integer it is supporting. Some are supporting 2 bytes integer, some are supporting 4 bytes integer. So I won't bother about it. Whatever you support, I need a size of integer. So I'm just using that operator. Size of operator, it is called as, if you remember, we have already discussed this, that size of is an operator, is not a function, even though it looks like a function. Okay. So what will happen now? If the compiler is having 4 bytes of integer supported, then it is going to allocate a memory piece of 4 bytes. Okay. It is going to, and let us say that its address is 500. So 500 to 503, this block will be allocated for this purpose after this allocation. Okay. But I want to store an integer over there. So I need to typecast that pointer as integer pointer. So when 500 is returned, 500 will not be a void pointer, will be an integer pointer. So now I am sure that these 4 blocks, which are 4 memory bytes which are allocated, are going to store an integer. Okay, and let us say that its name is P. Okay, its name is P. So this way I can allocate a dynamic memory in for a particular purpose. Okay, I hope you have understood what do you mean by dynamic memory allocation. Okay, and also if I'm constructing a structure, just a moment. So if I'm constructing a structure, at that moment I can declare the pointer for that. Okay, so if I'm using a structure and trying to access the element, I'm going to use the dot operator. So this is just recalling, you know it. And if I'm using a pointer variable, you are going to use a arrow symbol. Okay, this way the elements will be accessed. With these two things in mind, in knowledge, we are going to work on the link. Okay, we are going to work on the link. Now, is it okay? Shall we proceed? Just prompt in the chat box, yes or no? Fine. So we'll proceed now. Now again coming back to the back discussion, how we can implement the linked list. See, implementation of linked list. Now further, implementation of linked list is nothing but playing with pointers. Okay, there are three types of linked list. One is called as a singly linked list, which will point to only the next element, or which will have only one pointer on one link in the data node, in the element node. Double linked list means it can point to the next as well as previous element in the list. It will store, as we are storing the next address, it is going to store the previous address also. And a circular linked list where the last pointer is going to point back to the first pointer. Likewise, we are going to study three different linked lists, but one by one we'll see to that. And right now we'll just go for the discussion of singly linked list. So, and this only we are going to implement at many cases. So singly linked list. How we can now store or program the single linked list. We'll just go for a logical view of that first, and then we'll try to understand how the things can work out. As I said, singly linked list or a linked list is a dynamic data structure. Dynamic data structure means we can go on adding elements to it till you consume all the memory. Well, you have a huge scope of creating a long list without bothering about its size or number of elements well in advance. As and when element will come, it can be directly accommodated in that memory. One is the first thing you'll have to keep in mind. Second thing is, every time one element comes, we are going to create a node of that linked list. That node will be well defined in advance, and that node will be added to the linked list. That node will be added to the linked list. Okay. And third thing is, it's a linear data structure, so we need to maintain the start of this linked list. So we must know from where the linked list is starting, and we must know where that linked list is finished or ended. These things we need to keep in mind when we try to program a singly linked. Okay, let us say that there are elements which are coming into picture one by one. Like 13 is the first element, then comes 25. We are just going for a example. Then comes 4. So these are the 5 elements which I want to store. If I'm trying to store these using arrays, I need to allocate 5 integer bytes in the memory, that too in a contiguous memory location, and store it. Now here in this case, we are not going to bother about what size needs to be reserved in advance. We don't need to bother how many elements are coming into picture. As and when one by one elements are going to come, we are going to add them in the picture or in the list. So let us say that we have got the first example that 13 is coming into picture. 13 is coming into picture, then we are going to create one node. We are going to create one node which will be allocated a space with malloc. Okay, let us say that it is stored at location number 250. It is stored at location number 250. Okay, so right now we'll say that this as a new node. We'll say this as a new node. How it can be operated on this way. Okay, what will happen? As soon as first node comes, I need to locate a first data comes, I need to create a node. Creation of node means what? We are constructing a node. We are allocating the space equivalent to the size of that node. So this statement which we have written is going to get executed. So allocate a space equivalent to that struct node, make it a struct pointer new. So now new will be your node which you want to, in which you are going to store the first element. Okay, new will be the node in which we are going to store the first element. So with malloc function, we have created a pointer called as new, right? Now, I'm getting disconnected from the presentation, troubling a bit. I hope it is visible to you. So with this new node, we are constructing a new pointer. So this is a new node, and it is located at 50. It is located at 250. Okay. So this way we can do. Now, this is the data field of node new, and this is a link field or next field of the this is next field of new, and this is data field of new. So this is new dot data, and this is new dot next. Okay. So new dot data will be 13. What is new dot next? Right now, we have just constructed one node, and there are no further nodes in the memory. So this is called, this will be none. Initially, this will be none. So this is a node created. But has it become the part of list? No, not yet. We need to maintain a starting pointer for the linked list. So we are going to maintain a pointer called as head. If you remember the yesterday's discussion, we are going to maintain a pointer called as head, which will point to the first node of the link. Okay. So this will be again, this will also be a pointer variable of type structure, and is going to store the address of first node in the memory, first node in the linked list. Okay. So this way we are creating the first node. Let us say that we are now the second element has come. Second element has come, which is 25. Again, a new node will be created with the same malloc function. We can call it again and again in a loop. So a new function, new node will be created. Let us say that it is accommodated at location number 300. So its data field will become 25, and as it is a new node, it is going to be appended at the end of list. It is going to be appended at the end of list, and we can it is going to be appended at the end of list. Hence, it will be the last node. Always, it will be the last node. Fine. So this is now, this node is only created holding the value 20. Just keep me informed if I'm not audible in the chat box, because probably the battery of my headphone is going down. So you stop. Am I audible, Vedant?
Yes, sir.
So just keep me informed or just type in the chat box if I'm not audible.
Okay, sir.
So now the new node is created, but this new node needs to be the part of linked list. So it needs to be appended onto the linked list. It needs to be appended on the last node where the linked list ends. Right now, in this situation, this is the first node and last node are same. So its field is 9. I'll just change the microphone.
Am I audible? Vedant, am I audible?
Yes, sir.
Okay. Fine. So it needs to be appended as the last element of the linked list. So as soon as we can find here, this is the last node. So it is null. So remove null from that and store this address of new node into it. Address of new node. What is the address of new node? 300 over. Okay, 300 over. So this way the linked list will be created. Now this is the first node. This is the last node. Again, there comes the new node. There comes the new value. So new node will be created 4. This will also. Every time we are creating a node, we are naming it as new because previous nodes are already inserted in the linked list. Let us say that it is allocated at 400. So as it is going to be the last node, it will be null. And now this node is going to store the address of. This node is going to store the address of. Sorry. Address of this node. Okay. So 400 will be stored. So we can only find that adding an element into a linked list is just playing with pointers. Data is simply make new dot data is equal to 13, make new dot data is equal to 25, or make new dot data as a new item which is new element which is coming into picture. Okay. Only thing is we need to manipulate the pointer field, that is next field, very carefully. Right? So when it is the last node, it has to be null. When it is the node which is not last, it must hold the address of its next. Okay. So as soon as we get a new node to be inserted, like here in this case 53, if I am trying to insert, and it is located at location number 100, this 100 needs to be stored here. So as soon as 100 is stored here, we have created a link between these two. And it will be the last element, so it has to be made as null. Okay, it has to be made as null. So this way the linked list is going to get built up one by one. Now here, every time we insert a new node, the last node must take the address of this node as its link field. Otherwise, the last node is going to remain null. Once the new node comes, the new node becomes the last one, and this previous last node is going to hold the address of this new one. This way, the linked list gets constructed. Let us say that I am trying to delete this element. If I am trying to delete the element number 53, what simply we need to do? We need to make this field as null. We need to make this field as null and simply apply free function over here. So this will free up the node which is allocated. Or even if you are not freeing it up, if you are not bothering, that is not going to make any difference, because that will not be the part of linked list anymore, right? So this way your linked list gets constructed. So, and in the insertion of elements in the linked list or deletion of elements from the linked list are nothing but playing with pointers, playing with the next field of your node. It's simply like removing a person from human chain and adding a person in a human chain. You can add him anywhere, maybe at the beginning, maybe at the end, or maybe in between somewhere. It is possible through this dynamic memory allocation. So just manipulating pointers will be enough for you to understand how linked list operations can be performed. Okay, so with this, I'll stop here today, and we'll tomorrow find out. Tomorrow we'll continue with this discussion and the implementation of linked.